Hello, I'd like to do a quick demonstration of our new electronic workstation in operation. What I've got in front of me is a workstation with a few E-blocks on and a PC. Just to tell you a little bit more about the workstation itself, what we've got left to right is plus and minus 12 volt and 5 volt power supply, a 2-channel oscilloscope, signal generator and spectrum analyzer, an 8-channel logic analyzer with 2mm inputs, or those inputs also on a D-type connector, and here is a PC interface. It's an 8-channel PC interface that can be used with Flowcode, LabVIEW or Visual Basic. On the top of the workstation I've got some E-blocks, a PIC micro multiprogrammer. On port A I've got a sensors board, on port B I've got an LCD board, port C, which is the comms port, I've got an RS-232 interface, and that's paralleled up with just an LED board. The output from the RS-232 board goes into a GSM modem, and there's a little SIM card just in the top there that you can't see, and the LED board I'm going to plug into the logic analyzer on the front there. And I've got a little program in here that is basically a text messaging system. So first of all I'm going to just set that up, and on the display you can see it says enter phone number, so I'll enter my mobile phone number. Followed by a hash. Then it wants me to enter a message, and I'll just say hello, and then it wants me to confirm it. But before I do that, I want to demonstrate to you why this particular setup, the workstation and E-blocks, is really good for communications. Now what I've got here is a piece of software called a USB EE, which is actually embedded inside the workstation. And one of the things you're able to do with this workstation is set up a special communications monitoring system. This is basically a logic analyzer, but you can set it up so that 2 of the pins, you can hopefully just see them there, this is pins 6 and 7 of the inputs, are set up to be RS-232 inputs with RX and TX. And what I've done is, you probably can't see it, but there's a little trigger there which says that this logic analyzer is going to trigger and take a load of samples as soon as it sees a positive edge on bit 6. So I'm going to set the instrument to say capture once, and it now says stop waiting for trigger. So I'm going to go back to our mobile phone demo. I'm going to press the hash key a couple of times, which says okay, it's going to now send the message. And what you can do is you can see the AT command structure. So we've set up the LCD display so it's showing the different AT commands which are used to set up the GSM modem. An AT command structure is built on top of RS-232. And so what you can see now is the message has been sent. Hopefully my mobile will buzz in a moment. Oh yeah, there you go. It's saying a message has been received. And if I just tick on that, you can see that the message, I don't know if you can see that, it says hello there. And what you can also see if you go back to the workstation is you can actually see the sequential RS-232 commands here on the side of the screen. So this is why we've picked this particular device to go into the workstation. We really like it for showing how communications works. So here you can see the RS-232 lines, you can see their ASCII equivalent, or the decoding of the RS-232 lines, and you can see the sequential bits that have gone onto this, this bus. And there on the right hand side you can see the different commands. So here you can see part of it is AT plus CSM, and actually sending text messages with AT commands is relatively complicated, much more complicated than making a simple phone call. And so this combination of the logic analyzer, the decoder, along with all the eBlock software and hardware, we think is pretty good. I hope you've enjoyed that quick demonstration. Please check out our YouTube channel and our website for more video demos. Thanks for watching.